Okay, hi. So this is the first class meeting. This class is divided into, every week you'll have one lab and one class meeting. This is the first class meeting. Because of the format of this class, I'm not usually going to lecture at these class meetings. The content of the class is going to be given in lecture videos and notes online, and you'll see that all on D2L. Today I'm going to start lecturing a little bit because what else am I going to do? We can't do any problems or anything. But normally at these class meetings, bring questions. I'll answer any questions people have, and then we'll work through problems. I'll do some on my own, and then I'll give some to you to work through while I'm here. And so it's just a way to, it's a chance for us to make sure that we're on the same page with the stuff that's been delivered in the lectures. Okay, so that's going to be the idea. And then also this is where we'll do, I'll talk about this in the syllabus in a second, but this is where we'll do exams, and it's also where we'll do these short lecture quizzes. Everybody here, is everybody able to get onto D2L and see the content and stuff? So that I can communicate to, there's like 100 people in college physics total. And so I communicate to everybody through the same D2L. And so in D2L, it looks like you're all in section 11, which you aren't, but it's just so I'm not like typing the same exact stuff 4 different times. So that's why your D2L site says section 11, even though I think everybody here is in section 13 or 14. Okay, so today I'm going to go through the syllabus and the class structure. And then after I'm done with that, I'll go into a little bit of unit conversion. And basically I'm going to go over the material that's in the first lecture that I would assign you, so you can sort of skip that first lecture video, I think is how it'll work. And then hopefully by tonight, I'll give you I'll put the first assignment up on D2L, which will be a link to a lecture video and some notes that correspond to that lecture video, and then some problems to work on. And then, those are the kind of problems that if you have questions, we'll talk about those next week. Also, so this thing, like the reason I'm doing these lectures on computer and I turned on that recorder to start with is these class meetings, whenever I'm up here talking, I'm going to be recording those, and I'll put those on D2L too. So if you want to go back and look at problems that I've worked on up here, those are available. All right, so to get to D2L, you've all done this. Go to the main Normandale page and then D2L. And then, like I said, like I've closed all the sections of D2L except 11. That doesn't mean that, you're still in section 13 or 14, but on D2L, just go to this one. And whenever I put new stuff up, give new assignments, stuff like that, I'll put an announcement here. I'll put announcements up to remind you when tests are coming up and stuff like that. So just get in the habit of once a day, go to this D2L page and see if there's anything new up there. Okay, this is where I'll tell you where to look for new stuff. And you can see already since sections 11 and 12, we had our class meeting yesterday. That's a video of our class meeting. Okay, which is basically going to be the same as the video I'm going to put up of our class meeting. And then where I put all the materials and stuff is in content. So if you go to content here, the lecture notes are all here. The lecture videos are all on YouTube. But I'll put links to the videos. But so if you want, there's really two ways you can watch the lectures. One is you can act like it's a in-class lecture and just take your own notes, and some people like to do that. And then other people like to, these are the notes that correspond to what I'm writing in the lectures. So some people have liked to print these out before they watch the lecture video. And it has all my notes, and then you can just jot your own notes in the margins, and you don't have to write down word for word what I'm saying, because that's kind of here, So whichever, those both work fine. Whichever one of those you're comfortable with, that's what you should do. All the problems that I'm going to assign for the daily assignments are here. Solutions to all of those daily assignments are here. I'll talk about that more as I go through the syllabus. But so whenever you're working on a problem that I've assigned, and you get stuck, you can go to the solution, get a hint on how to proceed, then go back. And I'll talk about that more in a second, but that's all already posted. And then labs, if you want to glance at the lab ahead of time, you don't have to, but I'll put the lab up there. But I'll print out copies for you, and you can just show up and we'll learn about the lab. You don't have to do any prep work for that. Okay, so that's everything in content of D2L except the course information, and that's where the syllabus is. So that's where we're going now. So course information, syllabus. All right. As I'm going through this, please raise your hand if you have any questions as I go. I'd be happy to stop and answer questions as we go, anything that's not clear. Yeah. Oh, okay, great. Will you send me an email, and I'll fix that right after class. Thank you. So this is College Physics 1. The format is shown in those meeting times. Everybody has one lecture and one lab a week. Some weeks we'll cancel lab. I'll put that in the D2L announcements. Like, for example, I have a lab on Mondays. So the week of Labor Day, Monday is canceled. So we're just going to skip labs for everybody that week and that kind of stuff. It'll be on D2L. So lecture, I guess it's not really going to be a lecture, like I said, but those are the class meetings, and based on your section, this is where you meet. We're this right now. And then based on your section, this is where you meet for lab. My name's Dr. Lakin. I actually, my PhD is not in physics, it's in sort of mechanical engineering. But obviously there's like a lot of overlap. My office is 2302, so right up the stairs from where we meet for lab. The best way to get a hold of me is email. For office hours, I'm kind of planning to do, so I have 3 office hours scheduled all in the tutoring center, and the office number of the room number of the tutoring center is listed there. And then in addition to those 3 hours a week, I'm planning to schedule, one-on-one Zoom meetings or meetings in my office or whatever. I'm planning on a lot of those one-on-one meetings being scheduled. Otherwise, I would have scheduled more regular office hours. So please feel free to, whenever something isn't clear or whatever, send me an email. Maybe, if I can answer it over email, I will. Otherwise, we'll figure out a time that we can meet over Zoom. I'll send you a Zoom link, and then we'll just talk in person that way. Or, if you're on campus and I'm on campus, we can just meet in my office or whatever. So like I said, please do that because that's built into my schedule. I'm expecting that. Okay. There's no textbook for this class. Everything you need will come through the lecture videos, the class meetings, and the notes and stuff that I give you. So the only materials you need are a scientific calculator. So just a calculator that has trigonometric functions. That's what you need. It needs sine and cosine. So I know that there are always some people taking this class who are pre-med, and there are some other I can't remember what, maybe pharmacy school. There are some other professional schools where you have to take standardized tests that have some physics on them. And so for people who are going to have to prepare for standardized tests with physics on them, it's useful to have a book. So if you're looking for a book for future reference, that Giancoli textbook is a full textbook, which means it's expensive, but maybe you can find it used for quite a bit cheaper than it would cost in a bookstore. That's sort of the textbook that I kind of follow, so that if you're going to get a textbook, that one would probably make the most sense to match the way I talk about this class. But what I would really recommend, what works best for me is, instead of getting a real textbook, get the Shams outline for college physics. It's about a $20 paperback thing about this thick. It has very concise summaries of all the topics, so it's not as wordy as a textbook, but I actually like that. And then it just has tons of problems. Like some of them have full solutions and the other ones just have answers, but so if you're trying to get ready for a test or something, that's the thing to have. Just lots of practice working on problems. You don't need either of those for this class. I would recommend don't use any outside sources for this class. The best way to get ready for the way I write exams and stuff like that is just to follow the way I do problems in class and stuff, and the problems that I assign you. I'm trying to make the simplest sort of roadmap to the problems I want you to be able to solve. So outside sources, I think, just tend to sort of get people off in a different direction, Any questions about that yet? The only prerequisite is college algebra. But I've had people be successful in this class without college algebra. It's not really the college algebra material that's necessary as much as just you need a certain level of comfort with regular algebra, So if you're not done with college algebra, come talk to me, but there's a good chance it'll still work out fine. And the website for the class is that D2L site. The topics to be covered. So basically, Physics 1 is all about objects that are the size you can see and feel and stuff, and how they move when you apply forces and things to them that you can see and feel. So this is kind of a class full of stuff that you already have a part of a lifetime of experience with, That means you already have intuition about a lot of this stuff. And in a lot of cases that helps. In some cases that hurts, because in some cases your intuition is most likely wrong. And, the people who've already had their lab this week, that's a lot of what the questions on that exam are sort of getting at, like some things that are where your intuition is correct, and then a lot of those questions are on stuff where your intuition, almost everybody's intuition is wrong, and you have to sort of unlearn that and relearn the right way. Then if for the people who go on to Physics 2, that gets into stuff that you don't really have physical intuition about for the most part, electricity and magnetism, thermodynamics. But this is the stuff that's like, what happens if you take a ball and swing it around and throw it and it hits a cat and the cat runs, and like, you know, how fast will the cat be running? Okay, the grading scale for this class, I might lower this if the scores are lower than I expect on exams or whatever, but most likely, usually the grading scale is 92, 82, 70, 60. And people, there are always people who get a little nervous about the 92 and 82 because it sounds high, but that's really just a reflection of the way, like how similar my exam questions are to the thought process in the assignments I give you, you know. If you understand the thought process in the daily assignments and the weekly assignments, you're just going to do really well on these exams. People just score high on them. And I don't think you'll find that I'm a especially hard grader or anything, probably the reverse, if anything, you know. But yeah, so 92, 82, I mean, it's just because I don't give exams where people see questions and freak out because they've never thought of anything like that before. They look a lot like my homework questions, and I never have exams where the class average is 65 or whatever, you know. So that's all that is. To come up with that grade, it's divided up into these 1, 2, 3, 4, 5 things. Lab exams, lecture quizzes, daily assignments, weekly assignments, and exams. And so now I'm just going to go through what all of those are so you know what to expect. Any questions yet? Okay. So the labs, I will take attendance during labs, and you have to come to labs. A little more on that comes down later, but I don't really grade the labs. It's just sort of, were you here doing the activity or not? So the only way that the labs come into your grade, really, besides that you just have to be at labs, is through these 3 lab exams. And in those, I'm going to ask you questions that are similar to the questions I've been asking in the labs. They're worth a total of 10%, so each one of those is worth 3 1/3% of your grade. They're cumulative, so you have to, as you're getting ready for those, you need to go back and remind yourself of the lab, you know, like in that lab exam 3 in December, it'll have questions on it related to lab 1, lab 2, you know, so you just need to keep going back and refreshing your memory. If you can't make it to, you know, right there, it tells you the dates of these things. So if you can't make it to one of those, you need to talk to me beforehand. Otherwise, if you don't talk to me beforehand and you miss it, it's going to be a 0, which isn't a huge disaster because those aren't worth a ton of, but it's better not to have that happen. If you can't make it to your lab, you can always show up to the lab exam in any one of these other sections. There's room in those, and so keep that in mind. That's true of labs too, not just the lab exams. If you ever can't make it to your lab, but you can make it to one of the other 3 that week, you don't have to tell me ahead of time. Just show up and do the lab with them, and that'd be fine. Okay. Okay, so that's 10% of your grade. Then the lecture quizzes are 10% of your grade. So like all the assignments, the exams, those are all going to be problem solving using equations and stuff, coming up with numerical answers for things. But in order to build those skills, I need you to be watching all the lectures, paying attention to it, taking notes, and then going back and reviewing your notes. And so these lecture quizzes are just my way of checking that you're doing that. Just periodically reviewing your notes, reminding yourself how I did things, what I said. And so those are just going to be short answer questions about, what's Newton's second law, or, sort of big picture ideas that come up in the lectures. It says every class meeting. That's probably a little ambitious, but maybe every couple class meetings. I'll just finish the lecture, finish the class meeting, 10 or 15 minutes early, hand out these little sheets with 5 questions on them or something, short answer questions, and you write that down. And I'll drop the lowest 2 quiz scores. So if you miss a couple class meetings or you just do really badly on a couple, then those don't show up in your grade. Daily assignments. So whenever and this is going to happen probably by tonight, the first one, whenever I give you your lecture videos and notes to go through for that week, I'll also assign some problems to work on. Those will come from in D2L, the section that says daily assignments. And I do want you to turn those in because I want to make sure you're doing it. There are full solutions available for all of those. But you shouldn't look at the solutions. Like, here's how you should use those solutions. You should try to do those problems without looking at them. And then if you get stuck, use the solutions to get unstuck, and then try again to do the problem without looking at the solutions. If you're just going through and if you're looking at the solutions before you start working at it or copying the solutions or whatever, you're just not going to learn the material very well. Okay. So as far as the 10% of your grade that comes from daily assignments, you obviously could just copy the solutions that I've given and turn that in, and you get your full 10%, 10% of the grade. But it would really hurt how well you do on exams and stuff, so it's not a very good strategy. Oh, also, use those solutions. So after you finish a problem, if you know how to do it, after you're done, look at the solution and make sure that you're on the right track and not going off sideways. So I am going to, for these daily assignments that you're going to turn in through D2L. Yeah, question?
Yeah, when you're doing your daily assignments, let's say like you finish a problem and then you look at the answers and it's wrong, you want us to like grade it as wrong or like make marks on how we fix it to change it, or how do you want to
The best thing you could do for yourself, because think of this as just mostly getting yourself ready for exams. The best thing you could do for yourself is to try to do it again and do it the right way. I was just about to say, I'm going to collect these on D2L. You're going to turn them into a folder on D2L through pictures you take of it or scans you take of it. But I'm not going to grade it. I'm just going to look at it, make sure that you're putting in this amount of work that I think is important for understanding this material. So it's really kind of up to you to make sure that you're learning how to do these problems the right way when you do them. And you can always come and ask me questions, but I'm just not going to give you any meaningful feedback on these daily assignments. It's just too many problems for me to like grade through carefully. So, yeah. Any other questions about that? Yeah. I'm going to give due dates, but not really. I mean, I'll keep them open. You can turn them in anytime you want, but I'll give due dates just to try to keep you sort of on pace so you don't get behind. That's all. Okay, so daily assignments, that is the heart of this class. Like, if you understand how to do these daily assignment problems well, you understand the steps you have to take to do them, then you're going to do well on exams, well on the weekly assignments. That's the key to it. It's only worth 10% of your grade, but it's really like the heart of the class. Now, the weekly assignments are worth more of your grade, 30%, and they're going to be similar in difficulty to the daily assignments. You won't have solutions to those, and those are the ones that I'm going to grade carefully. Okay, so maybe every couple weeks I'll give you one of these, 2 or 3 weeks, and I'll grade those carefully, and it's just it's my way of checking that you're getting out of the daily assignments what you should be. Just like the daily assignments, you're going to turn those in on D2L. So when you're in both of these cases, when you're done with it, take a picture of it and submit that, or scan it and submit a PDF or whatever. And I'll always put folders on D2L for you to put that stuff in. On the daily assignments, I'll drop the lowest 2 scores. So basically, like you could skip a couple of those and it wouldn't affect your grade. Although you need to learn that material for the exams and stuff. And the weekly assignments, I said I'm dropping just the 1 lowest score of those. So if you do really badly on one of those, it doesn't have to mess up your grade. So for the weekly assignments, you're not going to be given solutions by me, but you can feel free to work with each other on these. So exchange emails or whatever, and feel free to work together. But the thing you can't do is just copy someone else's work and turn that in. So you can work together to understand the problems, but then you need to go off on your own and write out the solutions to the problems you turn into me. That's the way that you're supposed to work together to gain an understanding, you know? Yes?
So, for the exams, is it also going to be the same thing, like drop the lowest one, or?
Pretty close. That's the next thing I'm getting to. So yeah, exams. There are going to be 4 of those, and you don't exactly drop one, but if you do badly on one of the first 3 and you do better on exam 4, that exam 4 grade will replace the one that you did worse on. Okay, so that's sort of the equivalent of dropping an exam, you know. So if you get and actually I might not have mentioned this, but it's true of the weekly assignments too. Exams and weekly assignments are going to be cumulative. So everything is going to, so weekly assignments and exams are both going to cover all the material that we've gotten to up to that point. Okay, so that means that exam 4 covers the whole class.
So then weekly assignments basically just adds more and more.
Not more problems, but just more topics that you're responsible for. Yeah. So yeah, like in the weekly assignment, in the last week of the class, or in exam 3, there still can be material on those from the first week of class. And that is the exam schedule we're going to use. So if you can't make it to one of those, let me know ahead of time. And just like the labs, if you can't make it to your class meeting, but you can make it to the other one for the exam, feel free to do that. Yes?
So, this is like Wednesday, Thursday, so
Mhm.
we take the exam on both Wednesdays?
Oh, no. So you guys have your class meeting on Thursday, so you just take it in the class meeting on Thursday. Yeah, right. So like if it's an exam day right now, you'd be taking the exam right now. Yes?
One more.
Yeah.
The daily assignments, are you only gonna post daily assignments on Monday and Thursday when we have class, or are you gonna post them Friday?
I'll probably just do it once a week, probably Thursday. That's what I'm thinking. And I'll give you all the stuff you need to do for the week and give you a week to, work on it and stuff.
Okay, sounds good.
Okay, and then, so that's your entire grade. Exams are 40%, weekly assignments 30%, then 10 for the other stuff. So there's no single exam, final, weekly assignment, anything that would just destroy your grade if you do badly on it. And then the other thing that you have to do is you have to go to labs. Like I said, I'm not giving specific grades for labs. You just have to be there doing the activity. Really, when you're in lab, your responsibility is just trying to understand the stuff to get ready for those 3 lab exams. But I will take attendance, and if you miss 3 labs without talking to me and making those labs up, you fail the class. So basically, you just have to go to all the labs, and you can miss 2, and that's fine, although you're still responsible for that material on the lab exams. And you can go to any one of the other 3 labs any week you want if you can't make it to yours. Okay, and then cheating policy. This has become more of a problem during the COVID years because of the website Chegg. So I assume you've probably heard of this website. Like students can submit problems to them, and they have their tutors that write out solutions and post them back online. And so it makes it so students can, for a take-home exam or something, or a assignment, they can submit this thing to this website, get answers back, then they write out the answers and turn it in. That's obviously cheating. And if you get caught, here's in my class, this is how I approach it. And I got to tell you, it's pretty easy to catch for the most part. There are ways to do it so it's not easy to catch, but for the most part, in order to understand how to make it so I can't recognize it, you have to understand the material well enough that you might as well just not do it in the first place. You know what I mean? So anyways, I don't know. Maybe the people who made this website, Chegg, had wholesome ideas in mind. I'm sure there are ways to use it that's totally wholesome or whatever, but it has become like a cheating factory, and I would recommend staying away from it. If you look at a problem and you don't know how to do it, that's what the benefit of Chegg is supposed to be, that you can get help from their tutors. Well, just come talk to me or talk to other people in the class. That's really a better way to go. Okay, and then all material is available on D2L. So like I said, just look at the announcements every day. And, oh, well, apparently this has been more of an issue as we're coming back. Like everybody's just out of practice being together. Maybe it makes you a little like you're stuffed together for the first time in a couple of years and it makes you a little antsy or whatever, but just try to take a deep breath and not, like what can happen is like somebody, is always talking in class or doing something you don't like and you get more and more annoyed and then you snap and then so just try to take a deep breath and let's all work together, man. Let's be cool. You can call this number, I guess, probably later in the semester when if there's snow and stuff, you can call that number to find out if class has been canceled. But you can also just look on the announcements on D2L. I'll always post it up there. So that's maybe a better way to go. And then the last thing is Normandale has a great OSD office. It stands for Office for Students with Disabilities, but it really is more than that. They work with students who have bad test anxiety or learning deficits or whatever. If you think you might need help with testing accommodations and stuff like that, just go talk to them and they can help you with that. And they're really, really nice people to work with. So that's the phone number and the email there. All right, anybody have any questions about the class structure? All right, well, let's get into the first topic. It's not exactly physics yet, but it's getting there. And this is basically what the lecture videos are going to look like, by the way. So I'm taking a video as I talk of my screen, and so you'll see my pen move around on the videos. You'll hear my voice, and I'm also right now recording everything I'm doing right now. So after class is over, I'll put this up so you can recheck stuff if you miss things that I said. So the first thing we have to talk about is units and unit conversions. And I would recommend just, when I'm doing little sections of lectures like this, or when I'm working out problems, I would recommend that you just do what you would do if I was doing it on the whiteboard, just take notes on it, So every physics measurement has a unit. If you have a radar gun and you're measuring the speed of cars going down the street, the units are, miles per hour. Whatever measurement you take has a unit associated. Every unit in this class is made up of 3 basic unit types. Those are length, So units of length are inches, feet, yards, meters, miles, so on. The second basic type is time. So that's seconds, minutes, hours, so on. And the third is mass. So that's grams, kilograms. In imperial units, that's slugs. You don't hear that one very much, but that's so in units of like feet and pounds and stuff like that, the unit of mass is slugs. We're going to pretty much always use SI units. So that stands for, I don't know if I'm spelling this right, but it's French, Système International. I might be mixing up French and Spanish a little, but that's what the SI stand for. It's not English, but we'll just call it SI. And the SI units of length, time, and mass are meters for length, seconds for time, and kilograms for mass. And so every kind of measurement we take is going to combine these. I mean, it could be just one of those if you're taking a unit of length, say. But if you're taking a measurement of speed, it would be meters per second, acceleration, meters per second squared. It's just combinations of these things. In other classes, so later classes, you'll learn a couple of other basic unit types, like charge, for example, when you're talking about electricity. But in this class, this is all we have. One thing that we're going to want to do pretty often is convert from one unit to a unit of the same type. There's no way to convert from one unit to a different type of units. You can't convert from meters to miles per hour. But you can convert from meters to miles. And so often we're going to want to convert units to another unit of the same type. So for example, how many inches are there in 3.5 feet? You know, that's another way of wording convert 3.5 feet to inches. You're used to doing this in some cases, but we'll also do some complicated cases where you're going to want to have like a method for doing it. So I'm going to start with this sort of simple case, but I'm going to show you the method, and then we'll do a couple more complicated examples. So the general approach is this. Any two units of the same type, there's always a conversion between them. So for any two units of the same type, there's always a conversion between them. in this inches and feet example, for example, 1 foot is equal to 12 inches. And because those are equal to each other, the way you can think of this is in terms of conversion factors. So 1 foot divided by 12 inches, you know, if you divide something by itself, you get 1. So 1 foot over 12 inches is equal to 1. And that's equal to 12 inches over 1 foot. And since those are equal to 1, you know, anything you multiply by 1 doesn't change what you started with. So you can multiply anything you want by one of these conversion factors. Okay, these are the things. So this and this are what I'm going to call conversion factors. The factor just means that you're multiplying it to something. And so what we're going to do is multiply the original quantity by the conversion factor. And then cancel any units as if they're algebraic variables. So cancel the units like they are algebraic variables. Okay, well, there's 2 conversion factors. One of these is going to work and one isn't going to work. So I'm going to do the one that is going to work first. So we're going to start with our original quantity, 3.5 feet. We want to convert that to inches. I'm going to multiply that by the conversion factor, 12 inches over 1 foot. Since we have a foot here in the numerator and a foot here in the denominator, we're going to treat those the same way we would if they were algebraic variables, m or x or something. You can cancel those two. And what we're left with is 3.5 times 12 times inches, or 42 inches. Any questions about how that worked? And I'm going to use a shorthand for this instead of writing it out in parentheses and multiplications and stuff. I'm going to always, so start with 3.5 times feet. You know, think of it as a variable. And then there's the fraction bar. And I'm going to replace the parentheses with just vertical lines, just to save pen strokes. So 3.5 feet, and we're going to multiply that by 12 inches in the numerator, 1 foot in the denominator, and it just makes it nice and clear what's in the numerator, what's in the denominator, what's going to cancel. Okay, so that's the way I'm going to always write that. But so now the question is, what would happen if so I happen to choose the correct conversion factor, 12 inches over 1 foot. What would have happened if I would have chosen the first one, 1 foot over 12 inches? So what if I had chosen the other conversion factor? So I'd start with 3.5 feet. And I'd multiply it by 1 foot over 12 inches. Okay. Now, if you think of feet and inches as algebraic variables, nothing cancels. You see that? And so we end up with an answer of like 0.29, I'm just rounding, but 0.29 feet times feet is feet squared divided by inches. And that's not a wrong answer. That you could use that as a unit for distance, but no one does, and that's not what the problem was asking us for. So that doesn't really do us any good, okay? So what you want to do when you choose the conversion factor is you want to choose the conversion factor that cancels the unwanted units. Okay, so in this example, we started out with, where'd it go? We started out with 3.5 feet, okay? We want to get rid of those feet because we want to end up with inches. So feet is the unwanted units, okay? And so we start with 3.5 feet. And now we want to multiply, since feet is in the numerator, in order to cancel the feet, we need to multiply by something with feet in the denominator. That's the only way we're going to cancel this unwanted unit. Okay, are you with me on that? So, so that's how we know, looking at it, that we want to multiply by 12 inches over 1 foot. Okay, I'm going to do 2 more examples, bringing a little more complexity into it with each, on each step. So the next one, let's do one where the units are speed. So that means we have a combination of, a length divided by a time. So example. Express 61 miles per hour in meters per second. Okay, so first I want to be clear to myself about what here is in the numerator and what's in the denominator. So I'm going to write this as 61 miles divided by hours. Oh, and I didn't give the conversions. The conversions we need are 1 mile is equal to 1609.344 meters. And 1 hour is 3,600 seconds. Okay, so we're going to have to do this in 2 steps, and you can just do it all in one multiplication, but I'm going to first convert the miles to meters, and then I'm going to multiply by stuff that converts the hours to seconds. You could do it in the other order, multiplication you can do in any order. It doesn't change anything. So to convert the miles to meters, I'm going to multiply by either the conversion factor 1 mile over 1609 meters or 1609 meters over 1 mile. Do I want the miles in the numerator or the denominator to cancel the miles? Yep, denominator. So I'm going to put 1 mile down here, 1609.344 meters up here. And if you're following along as you go, you can see those miles cancel and our units of distance are meters, so that worked out perfectly. And the next thing I want to do is multiply by a conversion factor that gets rid of the hours, changes to seconds. The hours are in the denominator, so do I want the hours of my conversion factor in the numerator or denominator? Numerator, yep. So this time I'll put the 1 hour up here, the 3,600 seconds here. The hours cancel. And now you can see your units are meters in the numerator, seconds in the denominator. If you multiply out all those numbers, 61 times 1609 divided by 3,600, you get 27.26 meters per second. And now as I'm rounding things kind of at, yes? Okay, rounding. Yeah. So in your chemistry classes, they're very careful about significant figures. I do not care about significant figures because, I mean, maybe I would care about it if the chemistry professors didn't make such a big deal out of it, but I'll let them do that and I'll worry about this other stuff. So basically, I don't care how you round. I'm following just the steps you do, and that's the end of it. You could call that 30, and if you did the steps right, I might tell you not to round it to 30, but I wouldn't ever take points off for that, okay? Any other questions? Okay, so now let's do one where one of the units types is squared. So I want to express 38,640 yards per minute squared in meters per second squared. This unit type is acceleration, and we're going to get to that and use that a lot a little later on. And the conversions that we're going to use are 1 yard is equal to 3 feet. One meter is equal to 3.281 feet. And 1 minute is 60 seconds. Okay, so there are two new things with this problem that we haven't seen yet. One is that we have the time squared in the denominator of this unit. And the second one is we don't have a conversion that goes straight from yards to meters. Okay, so that means that we're going to have to do it in 2 steps. We're going to have to multiply by something that goes from yards to feet, and then we're going to have to multiply by something that goes from feet to meters. Okay, and we can still just keep doing it all in one line. Okay, so we'll start out with 38,640 yards. In the denominator, we have minutes squared. And in order to make that clear to ourselves, remember minutes squared just means minutes times minutes. So let's write those out like this. Okay, the first thing, and what this shows us, and you'll see when we get to converting minutes to seconds, is that we're going to have to multiply by one thing to convert the first minute to seconds, and then multiply by another thing to convert the second minute to seconds. Okay, and if you don't do it twice like that, you get the wrong answer. Okay. So first, let's go yards to feet. Our conversion factor is going to be 1 yard over 3 feet, or 3 feet over 1 yard. Which one do we want? Yep, 3 feet over 1 yard. The yards cancel, and now we have length units of feet. And now we want to go feet to meters. Do we want 1 meter over 3.281 feet, or feet over meters? Meters over feet. That is meters. And the feet cancel. And now, if you look through all the units we have left, the only length units we have are meters. So we've done that part. And now we go on to the time. Minutes are in the denominator. So our conversion factor has to have minutes in the numerator. So we'll have 1 minute over 60 seconds. And that cancels, let's say, the first one of those minutes. If we left it here, we'd have, some number in these funky units of minutes divided by, meters divided by minutes divided by seconds. Okay, it's not quite what we want yet, so we have to multiply one more time by 1 minute over 60 seconds. That cancels the second minutes. And now if you look through and find all the units that are left, we have meters over seconds squared. Seconds times seconds is seconds squared. And that comes out to 9.81 meters per second squared. And that is a number, a value that you're going to get used to in this class. Anybody know what that 9.81 meters per second squared is? Yep. Yeah, that's right. So near sea level on Earth, an object that's in free fall, and if there's not significant air resistance, that's the acceleration that something in free fall drops. Any questions about that one? Okay, let's do one more and then we'll call it a day. So let's say you have this big cube, the side lengths are 1 meter. And let's say it's hollow and you can open it up and fill it with stuff. How many 1 centimeter cubes could you fit inside this 1 meter cube? Yes.
So like for this one, will we convert it from feet and feet to centimeters?
So what steps you use like that just depend kind of on what units I give you in the problem. In this one, I'm going to just tell you that 1 meter is 100 centimeters. But notice that this is sort of a different wording of the question. So what this is really asking is for you to convert a volume of 1 cubic meter to 1 cubic centimeter. Okay. So we'll start out with our original value of 1 cubic meter, and I'll write that as 1 meter times meter times meter. And then one by one, we're going to convert each of these meters to centimeters. So the first conversion factor is 100 centimeters over 1 meter. And that cancels the first one of those meters. Then do it again, 100 centimeters over 1 meter. Cancels the second one. Last time, multiply by 100 centimeters over 1 meter. Cancels the third one. You can see that the units we have left are centimeters times centimeters times centimeters. So we're done. Multiply out the numbers and you get 1 million.
Also write as 300 centimeters cubed.
No, so if you multiply those that would be if you'd added those 3 centimeters. But if you multiply those 3 together, those 3 100ths, you get 1 million. Any other questions about that? Okay, so if you were trying to figure out if it's a good idea to spend your day filling a box this big with little boxes this big, the answer is no. That would take forever. So I just saved you all that time through the magic of math. Okay, so that's it for today. Maybe tomorrow morning, look on D2L and the first assignment will be up. And let me know if you have any questions.